Good morning, class, and welcome to this lesson on Magnetism 6, Fields Produced by Currents. Today we will be able to identify the direction of the magnetic field produced by a current in a wire. So, what I'm saying here implies something, and I'll move these over here. When we have a current in a wire, it's in the objective. When there is a current in a wire, a magnetic field is produced. So let's think about this now. So far, we have talked about wires being in a magnetic field. So we talked about having a magnetic field here, and there's a wire in the field, okay? But now we're not talking about that. Now we're just talking about a wire with a current. So there is no magnetic field present, we just have a wire. Well, what we know is that if there is a current in a wire, a magnetic field is produced. And this really is where the field of electromagnetism started. Was once we figured out that a wire carries its own magnetic field, there is a there oh excuse me there a current in a wire carries its own magnetic field. This is why if you ever do any sort of like land navigation with a compass, if any of you done that before, and there's high power lines here, there's these things that look like high power lines. You should never use your compass next to high power lines because these wires are carrying a lot of current, and these currents are going to produce their own magnetic field, and so your compass can go way off if you're next to something that is carrying a current. Okay, so here is a picture of a wire. Here's a picture of a wire, and we're going to have what we call right-hand rule number two. Right-hand rule number two. So in right-hand rule number two, it's very simple. You can see from these pictures, the magnetic field is in a circle around the wire. So this is the magnetic field right here. It's in a circle. In right-hand rule number two, our thumb is going to be the direction of current, and our fingers are going to be curled. Our fingers curled up are going to be the magnetic field. So, in this situation right here, both these situations, the current is going up. So I suggest if you take your thumb and have it pointing up and you pretend that you're curling your fingers around this wire, your fingers are going to go in this counterclockwise motion. If I cross this out and say the current is going down, your thumb would go down and then your fingers will curl in the opposite direction, in a clockwise direction if I'm looking from up top. Okay? So that is right-hand rule number two, and fields produced by a current. Now, we do have a formula for this. The magnetic field produced by a current carrying wire is the permeability of free space times the current in amps over 2 pi r, r being the radius away. We had that picture of the wire like this, and then we had the current going around it. This would be r, the radius away from the wire. So as you can tell here, the further the radius, so the higher the radius, the less the magnetic field. Okay, which is pretty logical. Once again, this is the permeability of free space. It's a constant, and it's 4 pi times 10 to the negative seventh Teslas times meters over amps. Okay, so this is a constant right here, something that would always be given to you on a test. Okay, so the hardest part about this right-hand rule number two is being able to look at a wire on a 2D piece of paper, looking at a wire on a 2D piece of paper and figuring out which direction the magnetic field is facing. So I'm going to start off with an example here. I'm going to draw a cube. Here. I hope this works out well. Okay, so we have a cube like this. Okay, a little bit off there. That's okay. I'm going to draw a line in the middle. So I'm trying to make a 3D picture here for you. Okay, I'm going to draw a wire going from the top of the cube to the bottom of the cube. And what I want you to notice here is that this wire is on this plane right here. Okay, this wire is inside this cube and it's on this plane right here, which is the dotted line. Okay, so if I say the current is going down, what is the direction of the magnetic field at this point right here? We'll call it point X. So if we have the field going down, you should take your thumb. Your thumb's going to be facing down, so you should do that right now. Have your thumb facing down and curl your fingers, pretending to go around this wire here. What's going to happen is your fingers are going to curl around this direction here. And if, I can draw that a little bit better, I think. I think I can draw that a little bit better. Let me try. A little more 3D-ish. I'll do a different color too. So your fingers are going to curl around this way, and they're going to come back forward again. So pretend that your thumb is pointing down. Pretend that you are holding a wire. You are holding a wire in your hand. Your fingers are curled around. What are your fingers doing at point X right here? Well, if your fingers are curled around this way in this clockwise direction, your fingers should be pointing back at your face. Your fingers should be pointing back at your face. So that means the magnetic field at point X is coming out of the page. Out of the page. At this point right here. And if we looked at, let's say, point Y right here, same thing. We have our finger pointing down and we pretend we're wrapping our fingers around this wire. Our fingers, if this is like on our page, our fingers would come into contact with the page. So at point Y right here on this plane is going to be into the page. Into the page. Okay? And quite frankly, that is one of the hardest things about these topics, is not so much that they're so difficult, but can you picture it on a piece of paper? Can you look at the piece of paper and figure out with your hand and with your perceptual ability which direction the field is facing? Because once you know the direction the field is facing, then a lot of the answers come naturally. I'm going to do a whole other video practicing some common examples like this.